Hello everyone and welcome to Azam Shah Weekly, and this video is brought to you by my course Test-Driven Development in iOS using Swift. If you're interested in learning about test-driven development, then this is the course for you. You can see this is around 6-hour course, and it starts with understanding what exactly is testing, writing your first tip calculator, understanding mocking, then creating the to-do app with end-to-end testing, unit testing, and also UI testing and user interface testing. So it has all of those different aspects of it. So once you take this course, you will be able to understand what exactly is unit testing, test-driven development, and how to do it in your SwiftUI iOS application. All right, so let's go ahead and get started with our application. Now, since we are writing unit tests, and our unit test will be testing the actual logic, actual domain, the user interface is already been created for you. Don't worry, we will come back to testing the user interface. We will learn about testing, how to write user interface testing using SwiftUI and using XCTest. But right now we are focusing on the actual domain, the actual logic part. So this is the interface for our tip calculator, and this is the SwiftUI code which is used to create this interface. If I go ahead and run the application, it does allow me to enter an amount, and I can select the tip percentage. There are only three options, 10%, 20%, and 30%. When I click on the calculate tip, it doesn't really do anything. So the whole idea is that when we say calculate tip, it should display the tip amount somewhere over here. Okay, so what do we need to do in this app? The user interface is already done, so we're not really doing anything with the user interface. But you can see that we don't really have any code to perform the actual calculation of the tip. So if I enter $100 or $50 and the tip percentage is 10% or 20%, then we don't have the code to calculate the tip. And that is what we are trying to focus on in this lecture. Only the domain logic, only the actual logic that is responsible for calculating the tip amount. All right. So we're not really doing anything with the user interface. We're not testing our user interface just yet. We will come back to the user interface testing later on in the course. We're just focusing on, okay, how can we test the logic? That if I press the calculate tip button, maybe the amount has to be sent to some place where it returns me the correct tip amount. So if $100 is the actual total and I press on 10%, then the tip amount should be over here $10. But who is responsible for calculating the $10 amount? And that is what we are focusing on, unit testing, and we are going to use test-driven development approach to create a model, a class, a domain object that will be responsible for calculating the tip. So let's go ahead and get started in the next lecture. All right, so now we have seen what the app actually looks like, and we can continue with adding a test target project. The test target project, the unit testing project, is going to allow us to write our test. And we will write our test to test the logic for a tip calculator. So I'm going to go ahead and click on editor, add a new target, and make sure that the iOS is selected because we are writing or creating our iOS application. In the filter box, go ahead and search for test. And you can see that it comes up with two different results, UI testing bundle and unit testing bundle. UI testing, as the name suggests, it is for user interface testing. We will learn about it later. And unit testing bundle is where you will write your unit test. These will be the tests that is going to use the data in the memory. They will be super fast, and that is going to allow us to test our actual logic of our domain, of our models. Let's go ahead and say next. Now you can go ahead and use any name you want over here. I'm just going to go ahead and say tip calculator unit test, and that's perfectly fine, but you can use any name you want. This will be the name of your unit testing project. And there we go. You can see that I have now added it. If I go ahead and open up the file, you can already see that it has a bunch of code that the Xcode has already written for us. We don't really care that much about this code, so I'm just going to go ahead and remove it. Now, a couple of different things to note over here. This is our unit testing project. This is a tip calculator unit test.swift file. You can add more files if you have more test cases. The first thing to notice in this particular file is that we are importing something called XCTest. And XCTest is a framework, a module that contains many different functions and classes that allow you to write and run your unit test. Next up, you see our name of your class. You can obviously name your class anything you want. I'm just calling it tip calculator unit test. But the important part to see over here is that how your class inherits from XCTest case class. And XCTest case is a very important class because it consists of a lot of functions, a lot of different things that you can use to run your test. So since our class tip calculator unit test is it's inheriting from XCTest case, then we can go ahead and use many different functions and we can write tests inside our tip calculator unit test class. All right. So let's go ahead and write a very basic test which has nothing to do with the tip calculator. Function. Now, the test that you're going to be writing will be in the form of functions, and that function will be the test. Whenever you are testing something, your name of your function should begin with the letter test, T-E-S-T. And then after that, you can do whatever you want. So I'm just going to say add two numbers. All right. So this is a test that we have just created. And this test it's a test because it begins with the letter T-E-S-T. If I don't use these letters, you will see that this is not a test. And how do I know it's a test? Well, keep your eyes right over here. As soon as I write test word and save it, you can see that it displays this, that it can be run or executed as a test. So it is required that you name your functions, you start your function names with the name test, with the keyword test, T-E-S-T. After that, you can write anything you want. I'm just saying adding two numbers. If I go ahead and just press the play button, this basically means that I'm running the test. Now, this test doesn't really have anything, so it's always going to pass. So we're not really testing anything. All right. So how do we test that we can add two numbers together and the result will be something other, like some other stuff? So let's go ahead and do that. If I say result equals to some sort of an input, let's say 3 plus 5, which is like 8, right? What if I want to check that if the result, the left-hand side is equal to right-hand side? For there, we have different kind of functions that are available to us. Since we have imported XCTest, we can use these functions which are called XCT-assert. Assert simply means that we are asserting, we are saying that the left-hand side is equal to the right-hand side. We are also, there you can see the different kind of assert. We are asserting in this case that the value of the expression should be returning true. But then there will be assert nil, assert true, assert false, and so much more. Let's do assert equal. In this case, we are saying that the left-hand side, which is this side, should be equal to the right-hand side. And if they are not equal, then your test will fail. So in other words, if I put the left-hand side as a result, which is 8, and on the right-hand side I put 10, do you really think that 10 is, or 8 is equals to 10? But you are asserting that it is equal, right? So do you think this test will pass or fail? Let's go ahead and run it. You can see that if I run the test, It fails, and it actually tells you that why it is failing. It is telling you that 8 is not equal to 10. The left-hand side is not equal to the right-hand side. The left-hand side is 8 and the right-hand side is 10. So in order to make this pass, we can go ahead and pass in the correct value, the correct assumption that we have, and run the test again. And now the test passes. Now you can run the test in many different ways. You can simply click on a single test, which is right beside the function, to run that particular test. That's perfectly fine. You can run all the different tests in the class, which is in this class. So if I have 5 different tests in the form of functions inside the tip calculator unit test class, I can simply click on this button and run all the tests. But if you want to look at a different view, you can also click on that icon for test and run and display all the tests over here also in the left pane. So there are multiple ways that you can do the same thing. All right. Now, we're not really writing tests for adding 2 numbers. We are building a tip calculator. So we need to write our test that is going to satisfy the logic for a tip calculator. So let's go ahead and get started with writing our first unit test in the next lecture. All right, everyone. So let's go ahead and get started with writing our first test so that we can calculate the tip. Now, keep in mind that we are using test-driven development, which means that we don't really have any code written. We are writing our test first, and the test will dictate that what code we have to write. So I'm just going to go ahead and remove these and going to go ahead and get started with the test. Now the name of the test should always begin with TEST test, and I would even say that the name would be very descriptive. All right. So you can go ahead and call this calculate tip, and that's perfectly fine. But I would even go one step further in writing the name of the test in a very descriptive way. Just as the name of the test should be descriptive, the name of the class can create a context of the test. So right now you can see the name of the class is simply tip calculator unit test, and that's fine. But how can we make it a little bit more descriptive, a little bit more wordy? When calculating tip based on total amount, so you can see that the name of the class, the name of the test case is so descriptive, and all the different tests that comes under when calculating tip based on total amount should come over here. All right. So test should calculate tip successfully. Great. So you can already see that how descriptive our test names are, as well as the class name, which is defining the context of the test. And it reads really nicely. When calculating tip based on total amount, should calculate tip successfully. Okay, good. So how do we calculate the tip? Well, we don't really have any code to calculate the tip, and that is the reason that we are using test-driven development. The test is going to dictate that how we are calculating the tip. So I'm going to go ahead and create an instance of tip calculator. You and I both know there is no such thing as tip calculator. That does not really exist. But that is the beauty of test-driven development. The test that I'm writing, I'm just assuming that this exists. And this is a unbiased test because I'm just writing stuff that don't really exist. So I'm not naming it in a particular way. I'm just naming it what I think it should be called. So I think it should be called tip calculator, but it can be called anything you want. Tip calculator dot calculate. And what do we need to calculate the tip? Well, we definitely need to pass in the total amount, like the total money that you spend on the meal, and the tip percentage. And I'm going to say 0.1, which is 10%. This is going to return me the tip. And now we can do xct assert, and we can assert that the tip that I will receive will be $10 because I am trying to find out 10% tip of the 100, and 10% of 100 is $10. If I try to build this, you can see that it's not even going to build because there is no such thing as tip calculator. And this is where your test is guiding you. Test is telling you that, hey, there is no such thing as tip calculator. So maybe you should go ahead and create something called tip calculator. You should not create tip calculator inside your test. That's your actual class. So we're going to go back to the tip calculator project, the iOS application, and we're going to go ahead and add a tip calculator in models folder. I'm just going to call it tip calculator. There we go. Let's go ahead and create this. Now, even if I create tip calculator, the unit test is a completely different project, completely different target. It cannot really see this file called tip calculator. In order for the tip calculator unit test project to recognize tip calculator.swift file, we need to make sure that this particular file, tip calculator, is added to both the targets. So I'm going to go ahead and check out the properties of the tip calculator.swift file. And right over here in the target membership, you can already see that the tip calculator is only available in the tip calculator project, which is our iOS application. In order for our tip calculator.swift file to appear in or to be accessible in the tip calculator unit test, we can simply go ahead and mark this checkbox. So now the tip calculator is also available in the unit test target project. Now the tip calculator should have one function, which is calculate, which will take in the total amount and tip percentage. It should also return some value, the actual tip, in double. So just so that this particular code can compile, I can simply go ahead and return some sort of a hard-coded value. Let's go back to our tip calculator. Let's go ahead and build it and try to run the test. Now, if you're running the test, we were asserting right over here that we should get 10 back from the calculate function. But we didn't really get 10 back. What we get back is 0. It's actually telling you that your test has actually failed. So now we have a test that is failing. We have to go back to the tip calculator and write it in a way that it actually passes. That is test-driven development. Your test is telling you that it is not passing. You need to make arrangement in your code to make sure that the test is passing. So what do you think we should do over here so that we can calculate a tip which is based on the total amount and the tip percentage? Well, if it's a percentage like 0.1, which is 10%, 0.2 is 20%, and so on, we can simply go ahead and say total multiplied by tip percentage. Let's go back to our test and run it again. We made the change. We're running the code again. We're running the test again. And now this time the test actually passes. So this is a great indication that how unit testing allowed us to design our system, because when we were writing our test, we didn't really have any tip calculator. We did not really have any calculate. We were running the test and it was keep on failing. But the test was kind of guiding us that, hey, maybe you need a tip calculator. Maybe you need a calculate button, a calculate function. And the calculate function should take in two arguments, the total and the tip percentage. And then we were assuming that we should get back 10 as a tip, which is a 10%. Now, one of the things that you will note about this test is this test is not really taking any input, right? I mean, we're just checking the logic. So we're not really sending any input to this test. And you should not have any input for the test. You should not wait for someone to press a button to run the test. These tests are independent. This means that you can run it 100 times or 1,000,000 times, and it should always produce the same exact result. This test is also independent or isolated, meaning that if I run this test in any order, if I have 100 tests, and if I run this test in any order, if I run it first one, if I run the 20th one or the 100th one, it will always produce the same exact result, pass or fail. So there is no dependency on this test, which is on some other test or some other outside world. And this test is only testing the stuff which is in the memory. So it's not really making a network call, downloading anything. It's a very simple test that is just testing the logic of your tip calculator. So these are called unit tests, and we implemented our tip calculator based on what the test was telling us to do. All right. So this is our first test. What other tests that can we think about? When calculating tip based on total amount, what test can you think about? So let's go in the next lecture and we will enter our next test. But meanwhile, you should start thinking about what kind of test you will be writing. All right, everyone. So now let's go ahead and move to our second test when we are building a tip calculator. And this test will be based on what about if we add a negative amount. Now we can use the same context when calculating tip based on an amount, but we can also create a different context, a different test case. So it reads much nicer when calculating tip based on negative total amount. This will be XC test case, and all the different tests that comes under the context of calculating the tip based on a negative amount will come under over here. Currently, we only have one test. So what should the test be? I mean, what exactly should happen when a person enters a negative amount? And once again, keep in mind that we are thinking about the actual domain, the actual logic. We're not thinking about the user interface. This is not a user interface test that we're writing. We are writing the unit test that is testing the brain, the heart, whatever you want to call it, the actual logic of the application. So I think when a person will enter a negative amount, we should throw an exception. Should throw invalid input exception. So some sort of exception we should throw, which should tell us that this is invalid input. Okay, so let's go ahead and continue. We will go ahead and say tip calculator. We will create an instance of the tip calculator. That's perfectly fine. Now we need to say that whenever we are calculating the tip and the total is minus something, a negative number, then it should throw an exception. So let's go ahead and say that. Tip calculator dot calculate, and let's say that if I'm saying minus 100, then it should throw an exception. And our test should check that if the exception is being thrown. Now, if the calculate function, this function is throwing an exception, this means that we need to call it with try so that we can call the exception. And using one of the asserts, which is called the assert throws error, we can check that if the exception is actually being thrown or not. All right, so let's go ahead and do that. For the expression, I'm going to type in whatever we have typed in over here. So that's going to go right there as an expression. Message, whatever the expression message is going to return, we are not going to check that. And for the error, now we can actually check that what kind of error is being thrown. And we are assuming that the error that we are going to be throwing will be error as a tip calculator error. tip calculator. Now we don't really have anything called tip calculator error, and this error will be of type tip calculator error, which we don't have, dot invalid input. So a number of things are wrong about this test because we can't really call the calculate function with a try. So I need to call it with a try because we are expecting an exception to be thrown. So that's not really going to work because the calculate function is a throwable function. The other thing is we don't really have anything called tip calculator error with invalid input. So all of these things are not even going to allow us to make the test pass or even run the test. So let's go ahead and tackle the tip calculator error type. So we'll go back to our model, and I'm just going to go ahead and create something called tip calculator error, which will be using the error protocol. All right, there we go. And in this, we can go ahead and say invalid input, and that's a very basic kind of the error. All right, so now we have the tip calculator error. Now let's go over there and build it. Okay, and let's go ahead and run the test. Now, if we run the test, you can already see that it's complaining on line number 27, and it's basically telling you a warning that although you're calling the calculate function of tip calculator with a try, this particular calculate function does not throw any errors, or it's not a throwable function. So even though you're calling it with the keyword try, it's not really going to throw any error. And the test actually failed. All right. Actually, I don't want to run the test again because we already know it failed. Let's go ahead and see what the error is. Did not throw the error. So basically the error or the test is failing because we expected the calculate function to throw an error because we are passing in negative 100, but in the end it never did throw an error. So this means that it is an indication that I need to go back to my tip calculator and adjust this so that it will call or it will throw an error. So let's go ahead and write the code because our unit test is telling us that your test is failing because your calculate function is not throwing an error. In order for the calculate function to throw an error, we will mark this with throws. So now it's a throwable function, it can throw errors. We will check if the total is less than 0, then we can go ahead and throw the error by saying tip calculator error dot input. All right. It's the unit test that is telling us what to do. Now let's go back to the unit test and let's go ahead and run this test again. Now, since we have marked that with throwable, we have to call this tip calculator function with try. Now you can use any kind of try you want. Since I'm writing a unit test, I'm just going to use try exclamation mark, which means if something happens and it doesn't return me an actual value, it's going to blow up. That's perfectly fine for now. That's fine. Let's go ahead and run the test again. And now the test is passing. Let's go ahead and run the other test again, the first test. And you can see the test is also passing. All right. So now we have created the actual logic of the tip calculator using our two tests. Test should calculate successfully and should throw error when the input is invalid. There are not many other tests that are required from a domain perspective. And the reason is that our interface is quite strict. A user cannot really enter the tip amount. They can only check or they can only select the percentages. So it's not like somebody can enter a 50% tip or a 100% tip or a negative 100% tip percentage, because they can't do that because the interface doesn't really allow you to do that. So there's no point in writing those kind of tests because it doesn't really map to the real world. In the real world, your tip calculator is only asking for the tip amount, which we enter right over here. It doesn't really ask the user to enter the tip percentage amount. They can just select it using this segmented control. So you can see that you should write the tests that are actually part of the story of your application. Now, we still have to make sure that our tip calculator app or our content view is utilizing the tip calculator. So in the next lecture, we are just going to go ahead and integrate our tip calculator into our UI, and you'll be able to learn that it should work correctly because we have already figured out that it is working fine, and we have already made sure that the heart or the brains of the application is working correctly because of the writing of our unit test. So in the next lecture, we are just going to integrate the tip calculator model that we have created into our content view. Now we are done with our testing. Let's go ahead and see that how we can integrate our tip calculator model into our application. We have already written our tests, the 2 tests that we wanted to write. Now we can go ahead and integrate tip calculator and use it. Okay, so let's go ahead and take a look at our code. You can see that we have a button event, which is calculate tip. Right inside the button event, we can go ahead and calculate the tip. So let's go ahead and do that. We're going to call tip calculator. But first, in order to call tip calculator, we need to create an instance of the tip calculator. So let's go ahead and create an instance, an object of the tip calculator. Tip calculator equals to tip calculator. And now going back to the button click, we can go ahead and use it. Tip calculator.calculate. Now, one of the important things you will note over here is that the calculate function is a throwable function. So we can't simply call it like this. We have to wrap around with do catch or use some sort of an error handling mechanism over here. All right. So let's go ahead and call calculate. Now we need to pass in a couple of different things. We need to pass in the amount the person has entered in the text box. And we also need to pass in the percentage. The amount is easy because whenever you are writing something in the text box, it is going into the total variable, which is marked with string. But that is a string, we need double, so we need to go ahead and convert it. So let's go ahead and do that. Guard let total equals to double, and we will go ahead and convert our string to double. If it doesn't convert, then we will simply go ahead and return it. Okay, great. Now we can go ahead and pass in our total. And for the tip percentage, we can go ahead and pass in the tip percentage. Now we can't really call calculate like this, so we're going to go ahead and use try. And we can wrap it with do block, catch the error, and for simplicity, we're just going to go ahead and print the error for now. Let's go ahead and select all of these things and say Control I so that it formats a little bit nicer. Okay, now calculate function is going to return you the result, which is the actual tip. And we can easily display the tip anywhere on the screen. So you can see that we are displaying the tip right over here. Now you might be tempted to simply use result and kind of like display it like this. Result. Obviously result is not available right now, but if we make it a state property, then it will be available and we can use it like this. But this is a bad way of doing things. And the reason this is not a good way is that you're calculating, you're hard coding that the tip will always be in the dollar amount. But the tip will not be in the dollar amount. If I am in a different part of the world, then my currency is not dollar, It might be euros, it might be rupees, it might be anything else. So it's always a good idea to use a number formatter to format the currency. So I'm going to use formatter, and you can see I'm using number formatter. Formatter dot number style currency. So because we are going to be displaying currency, and tip equals to formatter dot string, and we can simply calculate the tip from the result. So we're simply formatting it in a nice way so that we can display it. All right, let's go ahead and build it. Okay, great. Now another thing that we need to do is we need to reset our tip and also the message so that every time it is starting from scratch. So we're just going to go ahead and assign this to be like empty strings over here for now. And for any kind of error that we're going to be throwing, we can cache that error. So let's go ahead and cache the tip calculator error dot invalid input. If we cache that error, then we can simply go ahead and set this up to be invalid input error. But if this is not the error, then we're just going to go ahead and catch more of a generic error, and we're going to get the description and display that. All right. This is where you can actually assign some sort of a string also saying that this is more of a generic error that caused it. Let's go ahead and give it a try. I'm going to go ahead and run the app. Let's go ahead and put some tip amount over here. Let's say 100, calculate, and it comes out to be $20. You can see that it already added dollar amount or the dollar sign because my local currency where I am on my iPhone is set to be US dollars. But if your local currency is euros or some other currency, then it will display the tip amount with that particular sign. So that's the benefit you get when you're using the number formatter. Let's go ahead and calculate 10%, 30%, everything working fine. What about if we go over here and enter something that you cannot calculate the tip on? So now you can see some problems going on, right? You can see that when we enter something over here, it doesn't really display the stuff. And the reason is that it is going right over here because you're not able to convert a total into double. So that's why it goes to the else clause and it simply kind of fails at that point. Now, if you want, you can go ahead and enter something over here, invalid input. But this is something that you will have to write your UI test to achieve it, to see that if it's working correctly or not. All right. So let's go ahead and run it again. And we will enter some characters over here, calculate tip, and you can see invalid input. Now, another thing that we need to check is if you enter the input amount, the total amount, which is negative numbers. Negative numbers, you cannot really, the amount or the total amount should not be the negative number. It should always be a positive number. So you can also see that it is also giving you invalid input. So you can see that with writing our unit test for the core of the application, meaning the tip calculator, we were able to create the whole app. And if I make any changes to the tip calculator, then I will be certain, I will be very confident that if my changes will break something, then my test is going to capture it so that we can capture it in our test and not with our customers telling us that, hey, there's something wrong with the tip calculator. So this is great. We have completed this app. You can see it's perfectly working, and this is a good start for learning about test-driven development in iOS.